Welcome to the deep dive. We're here to sift through the data, the research, the sources, and pull out the key insights, the really surprising facts, just for you. Today, we're diving into something maybe a bit unexpected, but absolutely vital for industry: the global fixed pyrometer market. We've got research from Cognitive Market Research, and our mission is to figure out what's really going on here.
Right, and maybe just quickly, for anyone wondering what a fixed pyrometer actually is, think of it as a thermometer that doesn't need to touch anything. It measures temperature from a distance by basically detecting the infrared heat an object gives off. Super useful.
Okay, so non-contact temperature measurement. Why is that so important?
Well, imagine trying to stick a regular thermometer into molten steel, or onto a spinning glass bottle fresh out of the furnace, or even onto a, super sensitive computer chip during production. You just can't. Or you wouldn't want to. It could be dangerous, or it
Yeah.
could ruin the product. So these pyrometers are essential where contact is impossible or just a bad idea. They're like the eyes of automation in really tough environments.
Got it. That makes perfect sense. So these tools are working away behind the scenes in all sorts of places. The big question then is, what's the global market actually look like? What's the data telling us about its health and where it's headed?
Okay, let's look at the numbers. Globally, back in 2021, the market was sitting at around $454.5 million. The projections show it climbing steadily. We're looking at about $574.1 million by 2025, and then a pretty significant jump to roughly $916 million, $915.995 million to be precise, by 2033.
Wow, okay, so nearly doubling in about a decade. What's the growth rate on that?
That works out to a compound annual growth rate, or CAGR, of 6.014% over that whole period.
6%. Okay, that's pretty solid, especially for what sounds like quite specialized equipment. What's fueling that? What are the key drivers behind this consistent global growth?
It really boils down to the increasing need for this kind of precise, non-contact measurement across a whole range of industries. Think about it. Manufacturing is getting more complex, more automated. There's a huge push for better quality control, greater efficiency, worker safety, reducing waste. Pyrometers help achieve all that. We see huge demand in metallurgy, for instance, glass manufacturing definitely, and also semiconductor production, where temperatures have to be incredibly precise. Even tiny errors there can be catastrophic.
Right, so it's tied into broader trends of industrial automation and sort of refinement.
Exactly. And new materials, new processes often demand non-contact methods.
That gives us a good global baseline. Now, I'm always interested in the regional picture. Where are the growth hotspots? Are there any surprises when we sort of zoom in? Let's maybe start with North America. What's the story there?
North America definitely holds a big piece of the market. The U.S. is the leader, no surprise there. In 2021, the U.S. market was about $100.1 million. That's projected to hit roughly $187.5 million by 2033.
And the growth rate for the U.S.?
Solid, at 5.168% CAGR.
Okay, so the U.S. has the biggest slice, but is it the fastest growing in North America? Sometimes the established leaders aren't.
That's a good point. And actually, no. Canada is projected to grow faster. Their CAGR is expected to be 6.631%, reaching nearly $30 million, $29.792 million by 2033, likely reflecting ongoing upgrades in their industrial base. And Mexico's not far behind either, showing strong growth at 5.705% CAGR. That's probably linked to its expanding manufacturing sector.
Interesting. Okay, so North America is strong, with Canada showing a bit more acceleration. What about across the Atlantic? Let's look at Europe. Similar story, or different dynamics?
Europe's also a major market, definitely. It's expected to grow from about $85.4 million in 2021 to nearly $165 million, $164.788 million by 2033. The overall CGR for Europe is pegged at 5.516%.
And within Europe, the usual suspects leading the way: Germany, France.
Yes, those are key contributors. Germany is significant, of course. Interestingly, France is actually projected to grow a bit faster among the larger economies, at 6.266% CAGR. Might be linked to aerospace and automotive demands there. Then you have the UK, Italy, Russia. They're showing more moderate growth, kind of in that 4.6 to 5.9% range.
Okay, but looking at the data, something jumps out. The rest of Europe category, this includes what? Eastern Europe, smaller Western European nations?
That's right.
Their growth rate is forecast at 7.101% CAGR. That's noticeably higher than the big players. What's going on there? That seems like a bit of a surprise.
It is interesting, isn't it? It really points to increasing tech adoption in, let's say, the emerging EU economies and other nations in that group. Many are modernizing their industries, sometimes with EU support pushing for higher efficiency, better quality. As they upgrade, the demand for tools like precision pyrometers just shoots up.
Right. Catching up and integrating more advanced manufacturing. Makes sense.
Now, if we shift focus to Asia-Pacific, this region is definitely one of the powerhouses for growth. It's a very dynamic industrial landscape right now.
And I imagine China's a huge part of that story.
Absolutely. China's market was around $54 million back in 2021, and it's expected to basically double, reaching nearly $109 million, $108.834 million by 2033.
Okay, dominant volume again. But like we saw in North America, is there maybe a country with an even higher rate of growth in Asia Pacific? It's sort of hidden engine.
There is, actually, and it's India. India shows the highest growth rate in the entire region, projected at a CAGR of 7.186%. That puts it ahead of Japan and South Korea in terms of growth pace.
Wow, over 7%. What's driving that boom in India?
It's really a combination of things: rapid industrialization, government initiatives like Make in India, and a really significant push towards automation and Industry 4.0 concepts in their manufacturing. Companies are investing heavily in smarter factories, better quality control, which makes these pyrometers essential.
And presumably Southeast Asia, places like Singapore, Taiwan, are also contributing strongly, especially with electronics manufacturing.
Yes, definitely. That whole block shows strong potential. Lots of infrastructure development happening. Plus, that high-tech manufacturing base relies heavily on precise temperature control.
Okay, let's keep moving around the globe. What about South America?
South America is showing a pretty robust growth trajectory as well. The overall CAGR for the region is expected to be almost 7%. 6.994%. That takes the market from about $30.5 million in 2021 up to around $67.1 million by 2033.
Almost 7%. That's quite strong. Any particular country leading the charge there?
Well, the data points to Argentina having the highest regional CAGR at a remarkable 7.533%.
Argentina. Interesting. Any thoughts on why?
It's likely tied to growth in specific emerging industrial applications there, maybe resource extraction or processing, plus broader modernization efforts. And actually, the rest of the South America category is also growing very fast at 7.342%. So it's quite widespread growth.
Okay. How about the Middle East?
The Middle East market is growing, projected to reach just over $30 million by 2033, up from about $17.3 million in 2021. The growth rate is a bit more moderate compared to some other regions, though, at 4.579% CAGR.
And within the Middle East, is there a standout?
The UAE shows the highest growth, forecasted 5.76%. This seems clearly linked to their ongoing push for industrial diversification, moving beyond oil and gas into areas like advanced manufacturing and aerospace.
Right. Diversification drives demand for new kinds of industrial tech.
Exactly. But if you're looking for the region with the absolute highest growth rate globally, we need to talk about Africa.
Africa, really?
Yes, Africa boasts the highest projected CAGR of any region, a really striking 9.607%. It signals huge untapped potential there for industrial process control and automation.
Wow, over 9.5%. That is astonishing. Does the data break that down further?
It does. And what's even more impressive is that the rest of Africa category, so countries beyond the typically larger economies, perhaps is forecast to grow even faster at 9.96%. Countries like Nigeria and South Africa are also showing very high growth rates, both above 9% individually.
Nearly 10% growth for much of the continent. What is fueling this incredible surge? Is it brand new industries popping up or upgrading existing ones?
It's likely a mix. There's a definite push towards domestic manufacturing in many African nations, significant infrastructure improvements happening, and a drive to adopt more modern industrial practices to become more competitive globally. Also, importantly, many parts of the continent are starting from a lower industrial base. So even relatively modest investments in things like automation and quality control tools like pyrometers can result in these very high percentage growth figures. It really suggests a continent gearing up to integrate more advance in tech.
That's a fascinating global tour. So if we take a step back now and try to connect all these regional threads, what's the big picture telling us? It seems like pretty consistent, widespread growth almost everywhere.
That's the main takeaway, yes. The fixed pyrometer market is on a steady upward path globally.
So what are the fundamental overarching forces driving this? Why are these specific instruments becoming so consistently important across such different economies and industrial stages?
I think it really boils down to a few key things converging. First, the relentless rise of industrial automation and, digital transformation worldwide. Everything's getting smarter, more connected. Second, there's just a much greater awareness now, globally, of how critical process efficiency and precision are. Competition is fierce, resources need to be used wisely, quality standards are higher.
And third, the technology itself keeps getting better. Infrared sensing tech is advanced, making these pyrometers more accurate, more reliable, maybe even more affordable in some cases. Put those together, automation, the need for efficiency, and better tech. And you see why non-contact temperature measurement is shifting from being maybe a niche tool to an absolute necessity for modern manufacturing, safety, and quality pretty much everywhere.
This has been incredibly insightful. Taking something like a fixed pyrometer and seeing how its market reflects these huge global industrial shifts, it's really telling. And it does make you think, doesn't it? Given this consistent, widespread growth in a specialized market like pyrometers, what other, maybe less visible foundational industrial technologies might be out there, quietly poised for similar global expansion as industries keep automating and refining?
That's a great question to leave people with. Think about other non-contact sensing, maybe for vibration or material analysis, not just temperature. How might advancements there reshape manufacturing or predictive maintenance or quality control? It's often these sort of fundamental enabling technologies that drive really profound changes, even if they aren't always the ones grabbing the headlines. They're the bedrock for future innovation in industry.
Okay, let's unpack this. We're diving into a topic today that might sound super specific, the global fixed pyrometer market. But trust me, this is actually a foundational technology. It underpins so much of modern industry, often unseen, quietly making sure things are safe, high quality, efficient. So this deep dive, it's really about giving you a shortcut, getting you genuinely well informed about this, well, fascinating and surprisingly important bit of tech.
It's true. Fixed pyrometers are absolutely crucial, really central to industrial temperature monitoring, and they're becoming more and more integral to smart manufacturing solutions, all over the world.
Mhm.
You might actually be surprised by just how far-reaching the impact is. It touches everything from, say, factory floor safety to the quality of stuff you use every day,
Yeah.
across a huge range of sectors.
Yeah, it's funny how often the tech that really powers our world is kind of invisible. So let's pull back the curtain a bit. To start us off, what exactly is a fixed pyrometer? What's the basic problem it's designed to solve?
Okay, so at its core, a fixed pyrometer is a device for non-contact temperature measurement. Think about places like steel mills, glass factories, or ceramic processing units, really hot environments. Temperatures there can hit thousands of degrees. It's incredibly hazardous. You need accurate, reliable temperature readings, right? But you can't put people or even regular sensors right in there. It's just too risky. So that non-contact capability, that's the key thing. It's a critical advantage for getting precision readings safely where, direct measurement is impossible or way too dangerous.
Right, right. So it's about getting those vital temperature readings, but from a safe distance. Sounds absolutely essential for any industry dealing with extreme heat. That's a clear win for safety and for accuracy, too. So given how important that role is, what's really driving the growth we're seeing in this market right now?
Well, what's truly fascinating here is the really strong link between these pyrometers and the whole Industry 4.0 movement. We're seeing manufacturers integrate these sensors directly into their automated production lines.
Okay, Industry 4.0. People hear that term a lot. Can you maybe paint a quick picture? How do these pyrometers actually fit into that smart factory vision? What does that integration look like on the ground?
Sure, sure. Imagine maybe a furnace, and there's a pyrometer constantly watching the temperature of a metal part being heat treated. In an Industry 4.0 setup, that pyrometer isn't just a passive gauge. It's like an intelligent node in the network. Its data streams immediately into the factory's main control system. And that system can then make real-time tweaks, adjusting the furnace heat, maybe the speed of the conveyor belt all automatically. It ensures quality, prevents defects without needing someone to constantly watch and intervene. It boosts efficiency and consistency quite dramatically.
Okay, so it's about that dynamic, almost instant control, catching potential problems before they even happen. That makes a lot of sense. Now, beyond the individual factory, are there bigger economic forces pushing this demand?
Oh, absolutely. If you look at the bigger picture, another really powerful driver is just the increasing industrialization happening in developing economies, particularly across Asia, Pacific, and Latin America. As these regions build up their manufacturing muscle, especially in sectors like metals, refractory materials, that kind of thing, well, the demand for reliable temperature tools like fixed pyrometers just skyrockets. They're investing in tech that helps cut down costly downtime and improve the product quality. And those are, crucial competitive advantages when you're scaling up in global markets.
Yeah, it's a natural step, isn't it? Bigger scale needs better control, more precision. But like with any advanced tech, getting everyone on board isn't always straightforward. So what are the main hurdles? What challenges are fixed pyrometers facing right now?
Yeah, there are definitely a few significant restraints. The first one that comes to mind is, well, the high initial cost. Advanced fixed pyrometers, especially the ones with all the digital bells and whistles, wireless connectivity, they represent a pretty substantial upfront investment, and that can be a real barrier, especially for small to mid-sized manufacturers. The ones with tighter budgets compared to the big players.
So the very features making them powerful, that connectivity, the advanced smarts, also bump up the price tag. Does that mean smaller companies are just priced out, or are they finding ways to make that investment pay off?
It's definitely a major consideration. Larger companies can absorb that cost more easily, right? Smaller firms often need to see a very clear, very fast return on investment, like proving it reduces waste significantly or boosts yield quickly to justify making that leap. Another challenge actually comes from the tough environments these things work in. Environmental conditions, think heavy dust, smoke, or something called varying emissivity. These can actually mess with the accuracy of their readings.
Emissivity. Can you break that down for us quickly? What does that mean in practice?
Yeah, sure. Emissivity is basically a measure of how well a surface radiates heat, how efficiently it emits thermal energy. Different materials, even if they're at the exact same temperature, radiate heat differently.
Yeah.
So if a pyrometer isn't calibrated precisely for the specific emissivity of the material it's looking at, or if that emissivity changes because, say, the surface gets dirty or oxidizes, its readings might not be reliable. This means companies really need to invest in proper calibration, sometimes even controlling the environment around the sensor, to get consistently accurate data in those harsh industrial settings. And then finally, in some regions, there's just a lack of technical expertise. Without people who are properly trained, the right setup, the ongoing calibration, just the long-term use of these quite complex instruments, it can all be hindered. It impacts how effective they really are.
Okay, so it's not just about buying the hardware. It's the tricky environments and needing the skilled people to actually run it properly. Those sound like pretty significant hurdles that definitely affect how quickly the market adopts this stuff. But looking past those challenges, where's this technology going? What are the really exciting developments coming down the pipe for fixed pyrometers?
Well, what's really fascinating now is how these pyrometers are evolving beyond just measuring temperature. We're seeing a lot more integration with AI, artificial intelligence, specifically AI-based predictive maintenance tools. This lets companies not just monitor temperatures, but actually use that data to forecast potential system failures, to optimize their operations much more intelligently.
Wow, that's a big jump. What kind of insights can AI pull from pyrometer data that you wouldn't get from just, raw temperature numbers?
Well, imagine a pyrometer constantly feeding temperature data from a critical part of a machine. AI can analyze tiny temperature fluctuations over time, picking out subtle patterns a human might totally miss or that a simple alarm threshold wouldn't catch. It could predict, for instance, that a bearing is heading towards failure, not because it's suddenly red hot, but because its temperature has been creeping up by, say, a fraction of a degree each week. That lets companies schedule maintenance proactively before the catastrophic failure, avoiding those really expensive unexpected breakdowns.
That's incredibly powerful, turning a measurement tool into almost a crystal ball for machinery health.
Exactly. And we're also seeing a big trend towards miniaturization and wireless connectivity. Newer models are getting much smaller and, crucially, wireless. That makes them way easier to install, especially in tight spots. And it makes them ideal for remote monitoring in, well, a much wider range of places. And here's where it gets really surprising, actually. The technology is spreading way beyond traditional heavy industry.
Oh, really? Okay, tell me more. Beyond the steel mills and glass factories, where are these sophisticated sensors popping up now?
Well, think about these rugged tools, originally designed for extreme heat, now shrunk down and working quietly behind the scenes for public health. They're being used in food processing, for example. Ensuring consistent cooking or chilling temperatures to prevent bacterial growth guarantees safety. They're also verifying sterilization temperatures for medical equipment, making sure surgical tools are absolutely safe to use. We're even seeing them pop up in scientific labs for really precise temperature control during experiments. It's quite a leap, isn't it? From monitoring molten metal to making sure your dinner is safe or a scalpel is sterile.
Wow, so it's really shifted from being this heavy-duty industrial workhorse to becoming this incredibly precise, almost unseen guardian in really sensitive areas. That truly highlights the transformation from specialized industrial gear to these smart, versatile tools that are becoming integral to, well, all sorts of automated and precision processes across so many different fields. So we've really explored the quiet power of fixed pyrometers today, from their crucial role in industrial safety and efficiency, through the growth driven by smart manufacturing, the hurdles like cost and environment, and then into this really exciting future with AI integration and these surprising new uses. It just highlights how these seemingly niche industrial tools are actually really dynamic, evolving pieces of innovation, quietly shaping things around us.
Indeed. I think the journey of the fixed pyrometer, from a pretty basic temperature sensor to this smart, connected device showing up everywhere, it really exemplifies how these foundational technologies keep adapting, keep finding new relevance. It really speaks to that constant drive for more precise measurement, which in turn pushes efficiency, safety, and innovation forward in so many diverse, often unexpected areas.
Which kind of leaves us with a thought to chew on, doesn't it?
Yeah.
How many other invisible technologies like this are quietly revolutionizing industries, shaping our world in ways we just don't notice?
Yeah.
And what other surprising transformations might they unlock in the very near future?